Okay, last topic. It says bonus y equals mx plus b and FOIL. And you're like, what does this mean? Well, first let's do bonus. Bonus means that I'm not really sure that you need to know this stuff for the SHSAT. All the release test questions from Pearson that appear on this site don't really go into this knowledge directly. However, other test prep books out there, especially Kaplan, does say you need to know this and you do need to know this. So that's why I call it bonus, because I guess a lot of people preparing for this test do delve into these subjects, so you should too. Wouldn't want to leave anything out there. But I don't know if it's the best use of your time, because there shouldn't be that many questions on the test if there are any. However, you are a math nerd and you're going to know this eventually, so why not learn it now? All right. So Pia is selling grilled cheese sandwiches. She wants to make a graph of her money. Yum. And this is a question you'll probably run into in 6th and 7th grade. You're like, all right, so here we go. Money in, and you sell 2 sandwiches, you get $5 in the register. You sell 4 sandwiches and you get $10 in the register. You sell 6 sandwiches and you get $15 in the register. And you're like, is this a proportional relationship? And you know the answer is absolutely yes. It's a proportional relationship because the graph is straight. It's a straight line, also known as linear, and it goes through the origin. It goes through 0, 0. So what's the equation for this graph? And you'll probably have run into it written in this format: y equals kx, where k is the constant of proportionality. If you've never seen this term k for constant of proportionality, don't get too upset. You don't really need to know that the letter k is sometimes used. It just means rise over run. So how do you make this graph into an equation? If you have your y-axis here, which you always do, it's always going up and down, it's always vertical, and you have your x-axis here, you always do, it's always horizontal. How do you find out how many x you have, or how many y you have, or how many y you have, or how many x you have? You use the constant of proportionality, and it's the rise over run. So what's the rise over run here? Well, you go up 5 over 2. So you go up 5 and over 2. You rise 5 and you run 2. So you rise 5 and you run 2. 5 divided by 2 is also known as 2.5x. And that's handy because if Pia wants to know how much money she'll get in the register, if she sells, like, I don't know, 100 sandwiches, it would be a really long graph to make. It would be a really super long graph to make. But with the equation, she can say, oh, that's just 100 sandwiches, 100 for x. 100 times 2.5 is 250. So I know what my y will be for that value of x. Indeed, I know what my y will be for any value of x. Okay, so that's a review of 6th and 7th grade. Now we're on to new material. Pia wants a more sophisticated graph. That is, she wants a graph that takes into account the $50 she spent on supplies to make the grilled cheese in the first place, and still yum. Okay, so this is her new graph. Think about it, right? How many dollars does she have in earnings when she has sold 0 grilled cheese? Well, she has negative $50, right? Because she spent $50 to get the supplies. How much money does she have after she sold 10 grilled cheese sandwiches? Well, then she has negative 25, right? Because she's got $25 in the register, but she already spent 50. So 50, negative 50 plus 25 is negative 25. Just take a moment, absorb it. It's not too complicated. It's pretty straightforward. This is her earnings if she had spent $50 to buy the supplies in the first place. What's my rise over run? What's my constant of proportionality? Well, you think your rise is 25, your run is 10, so it's the same deal. It's still $2.50 per sandwich, right? Because you rise 25, you run 10. 25 divided by 10 is still 2.5. So it's the same kind of rise over run, also known as the same constant of proportionality, but it's not a proportional relationship anymore. That's the big change. So constant of proportionality is wrong. We need a new term, right? Because a proportional relationship is a graph that is a straight line that goes through 0, 0. And this isn't going through 0, 0. At x equals 0, you're at y equals negative 50. So constant of proportionality is wrong, wrong, wrong. We need a new term. And here is our new term. It's called the y equals mx plus b, or slope-intercept form. And now m refers to rise over run. I don't know why they changed it from k to m. I guess it's because k is constant of proportionality, which goes to 0, 0, and m just goes anywhere in a straight line. So now we're dealing with m's and not k's, but it's still rise over run, and b is your y-intercept. So that's what y equals mx plus b means, is a slope-intercept form of a linear equation. Why is this a linear equation? Because it is a straight line, and that's what you need to know. M equals slope or rise over run, and y equals the y-intercept. Okay, so how does this work? Again, y equals mx plus b, or y equals rise over run times x plus the y-intercept. Well, what is my rise over run? And again, we just went over this. You rise 25, you run 10. Does it work for anywhere on the graph? You betcha. Here, you're starting out at 20 sandwiches, and that's where you broke even. Now you've made $0, right? Because you made back your money to buy some supplies. Everything else in the future here is money in your pocket, but this is where you break even after selling 20 sandwiches. So what's your rise? Well, you rise 25, you run 10. From 20 to 30 is 10. Same thing here, you rise 25 from 25 to 50, and you run 10 from 30 to 40. So y equals rise is 25, run is 10, x. And what's my y-intercept? Remember, you add the y-intercept. Well, the y-intercept is where you shockingly intercept the y-axis. So the y-intercept is negative 50. So plus the y-intercept is plus a negative 50. Okay, so let's clean that up. Y equals 2.5x minus 50. All right, that's all it is. We're good to go. So question 1, which of the following is correct about y equals 5x minus 4? It is a linear equation. Well, how do you know it's a linear equation? Well, you have rise over run 5 over 1x, right? So it'll just go in a straight line. So that's it, yes. And it's y equals mx plus b form, so it is going to be a straight line. So we're good there. The slope is 5. Yes, the rise over run is 5. That's what the y equals mx plus b form is, so we're good to go there. And the y-intercept is negative 4. We just did this, right? B is your y-intercept. Here you always add b and y equals mx plus b. So if it's subtracting 4, you know your y-intercept is indeed negative 4. So all three are correct. And we're good to go. Question 2, which of the below is correct about the following equation? 2y equals 6x plus 10. And you're like, it's not in the y equals mx plus b format, and that makes me sad. Why? Because you have a 2y here. And you're like, I don't like that 2y. I got to get rid of that 2y. I just want it to be y. That is the anchor of this equation. So I want this 2y to become just like y. And then you're like, well, I know how to do this. I just divide by 2. And that makes 2y, y, and you're like, well, if I divide by 2 there, I have to do something to the other side of the equation. Shockingly, I have to do the exact same thing. Whatever you do one side of the equation, you have to do the same thing to the other side of the equation. Cool. All right, so 2y divided by 2 just becomes y. And divide this whole thing by y. You got to divide both terms by y. You can't just divide one term, right? You have to divide both terms. So you can factor out a 2 or whatever you want to say. It becomes 3x plus 5. So there we've taken this term and we turned it into the y equals mx plus b form. Okay, is it a linear equation? Yes. The slope is 3 over 1. It'll just go straight forever. The slope is 6. No! Now that we've done our work to get into the y equals mx plus b form, we know the slope is not 6 but 3. And the y-intercept is 5, you betcha. Okay, so 1 and 3 are correct. And we're good to go. Question 3, which of the below is correct about the following equation? You're like, no, it's not in the y equals mx plus b form, and that makes me sad because I want it to be in the y equals mx plus b form. Well, I know what to do, right? I'll just subtract 4 from either side, and that makes me feel a lot more comfortable about working with this equation. Why? Because now it's y equals 3x minus 4, which is in the mx plus b form. All right, is it a linear equation? Yes, because you just have 3x. So there we go, rise over run is 3 over 1. Is the slope 3? You betcha. Is the y-intercept 4? No, the y-intercept is negative 4. It's negative 4. Once you subtract 4 from either side of the equation, you'll find that the y-intercept, is negative 4. So 1 and 2 are right, and only 1 and 2, we're good to go. Okay, there's a lot more to it, but I think that's the basics of the y equals mx plus b form. So check mark, we're good on the FOIL. And you're like, what is FOIL? Well, let's go through it. Okay, so the y equals mx plus b form is all about linear equations. Here our slope is -2. You can have negative slopes, that's okay. So instead of rise over run, our rise is -2. So it is rise over run, but it's a fall over run, right? Because it's a -2/1 slope, and the y-intercept is where? 5.5, so you know it's above the x-axis, and that's a linear form, and we're pretty happy with that. Now, a non-linear form is something you're going to run into in your algebra lives, and you're going to be like, what is this? It's kind of strange. It's no longer straight. It's no longer a slope. It's just totally weird. It's like a smiley face or a frowny face because it curves. It's also known as a parabola, and the form is often written as y equals ax squared plus bx plus c. It is nonlinear because it is curvy. An example is y equals x squared plus 7x plus 10. So the a here, the coefficient of x squared, is just 1. And if you run into these questions on the test, the coefficient of the x squared component, the x squared term, is probably going to be 1. So that's what we'll just go with for now. All right, so how does it look? Well, what do you have to do with it? So it looks like x squared plus 7x plus 10, and normally what you're going to have to do is you're going to have to factor that. You're going to have to turn this into component factors that are just x terms. So this would be factored into x plus 2 times x plus 5. And you're like, how do I do this? Well, the term that everyone used to know when I was learning this, although it's kind of frowned on now because it's like not the best way to learn it because you really should be distributing and all the rest of it. But anyway, it'll work for you for this test, and when you get to algebra in your 8th grade year, you can kind of learn it a lot more thoroughly and in a better way. But this is what you need to know for now if the question even arises on the test. But it's FOIL. The term is FOIL because it says first, outer, inner, last. So how do you go from this to this and back again? How do you get from x squared plus 7x plus 10 to x plus 2 times x plus 5? Well, FOIL will help you. What does FOIL stand for? First, outer, inner, last. So what do? First, you take the first terms and you multiply them together. So the first terms are x times x. And what is x times x? You gotta know it is x squared. All right, that's cool. Now, outer. So what are the outer terms? Well, this is outer here and this is outer there. So outer is 5 times x, and there's an outer term that's 5 times x, and that's going to be 5x, a positive 5x. All right, now what are the inner terms? The inner terms are 2 and x. So let's multiply those two together, and what do we get? The inner terms give us 2x, another positive 2x. And finally, what are the last terms? Well, the last term here is 2, and the last term here is 5. So 2 times 5 is shockingly 10. Add it all up together, you can combine like terms, and you have x squared plus 7x plus 10. Wow, okay, so we went from this set of factors to that term, or that expression. You're like, okay, that's pretty cool. Well, how do you go backwards? And you just have to work it out, right? You can create, I mean, if you Google it, and this is a good thing to put in the Khan Academy because they have some good videos about this. But if you want to break it down on the test, it's going to work out nice and simple. In real life, it's going to be a lot more messy, but on the test, you're probably going to find a set of factors of the last term that can combine for the middle term. So it's not going to be x squared plus 8x plus 10 on the test. It'll much more likely be x squared plus 7x plus 10. Why? Because 7x can be, you can get 7x by getting x plus 2, x plus 5. It's not really messy as it would be if the middle term here was something along the lines of 8x or 15x or something that doesn't neatly fit into a set of factors of the last term. So when you want to go from here to here, from this top line to this second line, find the factors of the last term and find a way to combine them to get the middle term. We're going to practice this. I think it's really fun. I think math nerds agree with me that going from this top line to this second line is actually kind of fun. So if you're into it, we'll do a lot of examples and you get really good at it. Let's get to work. Okay, question 4. Which of the below is equivalent to the following expression? X squared plus 7x plus 12 over x plus 4. Okay, this is a good example of a question you might run into on the test. First step is you have 12. Well, how do I get to 12? I can have 1 times 12 to get me to 12. I can have 2 times 6 to get me to 12. Or I can have 3 times 4 to get me to 12, right? So I can have 1 times 12 to get me to 12. 1 times 12 is equal to 12. 2 times 6 is equal to 12. And 3 times 4 is equal to 12. Okay, so that is my kind of like factor tree, if you will, of how to get to 12. Now you want to have something where you can separate this into an x plus something, and then divide it by x plus 4 and get one of these terms. So what could you possibly do? Well, I think the answer kind of sets itself up for you, right? X plus 4 is going to be one of these top terms. Because if you have x plus 4 down below and you want to cancel out one of these sets, x plus 4 is going to live somewhere up on the top, right? Well, what follows with x plus 4 to get you to this top expression? Well, it's 4 and 3, right? Because the outer terms here, the last terms here, 4 and 3 will multiply together to get you 12. The other terms, x times x is x squared, and in the combining terms, that would be 3x, and that'll be 4x, which gets you to 7x, right? So you're good to go all the way around. Up here, you'll get x squared plus 7x plus 12, right? 3 times 4 is 12, 3x is 3x, and 4x is 4x. Added together is 7x, and x times x is x squared. So up here, you're good, and down here, you just bring over the x plus 4. Now, you cancel out the x plus 4, right? Because if you have a times b over a, no matter what a is, they can cancel out because anything divided by itself is 1. You just have b, you just have x plus 3, so that's our answer. We're good to go. Question 5, stay with me. Okay, so our term is negative 12. Our term is negative 12. Well, how do you get to negative 12? You can have 1 times 12, or you can have 1 times 12, which is, trade the negatives, right? Because 1 times negative 12 gets you negative 12, and negative 1 times 12 gets you negative 12. Either way you do it, you're going to get to negative 12, and that's where we need to go. We need to go to negative 12. Well, you can also have 2 times negative 6, that'll equal negative 12, or negative 2 times 6, that'll equal to negative 12. And the same thing with 3s and 4s, right? 3 times 4 is 12, so it doesn't matter where the negative is, just as long as one of them is negative, you will get to negative 12. Okay, so there's all the ways to get to negative 12, and we have positive 4x. So we haven't dealt with negatives in the last term, in the C term yet, but I think if you're with me so far, this next step won't be too bad for you. All right, again, we want to have this top term to be in its factors, so it's going to be x plus something and x minus something, right? You know it's going to be x plus something and x minus something because you need a minus and a plus in your last term to multiply together to get to a negative 12. So you know one of these is going to be x plus something and one of these is going to be x minus something. You also know that your answer choices are down here, and this is x plus 6. So you're going to divide out something to get to something else that looks like this. So one of these choices has to be x plus 6. Well, if one of these choices has to be x plus 6, what is the other choice going to be? Well, it's going to be x minus 2, right? And this makes sense because first, x times x, remember, let's do FOIL again. Your firsts are x times x, which is x squared. Your outers are x times negative 2, which is minus 2x, right? X times negative 2 is negative 2x. Your inner is 6 times x, which is positive 6x. And your last is 6 times negative 2, which is minus 12. We combine like terms, negative 2 plus 6 is indeed 4x, right? Negative 2x plus 6 is positive 4x. That makes sense, right? Negative 2x plus 6x will get you to positive 4x. Minus 12 is there, x squared is there. That is the same term as we have there, so this makes sense. These terms cancel out. We're left with x minus 2, and we're good to go. Told you this was fun. Let's keep rolling. Okay, so we want to get to 20. How do we get to 20? We get to 20 by 1 and 20. We get to 20 by 2 and 10. We get to 20 by 4 and 5. All right. Good to go. We want to take this top term and turn it into two expressions here, and we want the bottom term to be x minus 2. And you're like, whoa, wait, x minus 2? Wait, there's a minus here, but you have a positive here. How can that be? I don't understand this, I'm scared, but we can take this next step together. If this is a positive here, both of these terms have to be positive to get to positive 20, or both of these terms have to be negative. Right? Because a negative times a negative is a positive. So to get to positive 20, you can't have negative 1 times negative 20, negative 2 times negative 10, or negative 4 times negative 5. That makes sense. You know that. We are good to go. And you know they are both going to be the same because the plus sign means they either both have to be addition or both have to be subtraction. And this negative sign here means they both must be negative, because how else can you get to a negative second term? Okay? If you do a bunch, you'll never get it wrong. All right, so how do you get to 20 and then the numbers combine to negative 12x? Well, you have negative 2 over here, but even if you didn't, I think by this time you'll be like, well, I want to get to negative 12. 10 and 2 get me to negative 12, right? Negative 2 and negative 10 get me to negative 12, and that works. 20 and 1 will get me to negative 21, and 4 and 5 will get me to negative 9. So, you know, obviously, if I want to get to negative 12, I have to do negative 2 and negative 10. So negative 2, negative 10, just to make sure my FOIL is in good shape. I'll do my first, x times x is x squared. I'll do my outer, x times negative 10 is negative 10x. Inners, negative 2 times x is negative 2x. My last, negative 2 times negative 10 is positive 20. That equals x squared minus 12x plus 20. That's the same as that, so we're good to go. So we have this term, and we cancel out the x minus 2's because anything divided by itself is 1, and we have x minus 10. We're good to go. Okay, question 7. Just when you thought you got it, something else comes up and makes it a little more difficult. But these problems might arise as well, and you're definitely going to run into them in your math life, so let's do this now. All right, so how do we get to 9? We get to 9, we have plus and plus. We know we're both going to be the same because you have a plus here, and they're both going to be plus because we have a plus here. So how do you get to 9? We get to 9 by 9 and 1, and you get to 9 by 3 and 3, right? There's no other way to get to 9 by using whole integers like this. So 9 times 1 gets you 9, and 3 times 3 gets you 9. Which of these terms can combine in addition to get you 6? Well, obviously it's going to be 3 and 3. So how do we get to 0? We have this term here can be broken up into x plus 3 times x plus 3 equals 0. And you're like, all right, well, I'm in good shape here. If x, the answer is 3, right? So the answer's got to be A. Well, you're wrong. The answer is not A. Think about it. If you want to get to 0, what value of x would make one of these 0? And anything times 0 is 0. So you want one of these little contraptions, one of these little terms, one of these little parentheses guys to be 0, because that times the other thing will be 0. So how do you get this to be 0? It's not 3. 3 plus 3 is 6. 3 plus 3 is 6. It can't be 3. What is it going to be? It's going to be negative 3. Negative 3 plus 3 equals 0, and that will times anything. Here, 0 times 0, but 0 times anything will get you to 0. So the answer is negative 3. The head fake is it's not 3, it's negative 3. But, you know, now that you know it, it's pretty simple. We're good to go. Question 8, which of the below is a solution to the following equation? You're like, I just did this, I know how to do this. Okay, so we have 20 and we have negative 20. So we know the signs are going to be different. So we have negative 20 times 1 to get us to negative 20. We have 20 times negative 1 to get us to negative 20. We have 10 and 2. What else do we have? We guess we have 5 and 4. And again, you can have either of them be negatives. Doesn't matter which one, you're still, as long as one of them is negative, you're going to end up at negative 20. All right, so now you have x squared plus 5 minus 20 equals 0. And you're like, okay, so what group is that? And you're like, well, 5 and 4 are right next to each other on the number line, so 5 minus 4 is 1, and negative 5 plus 4 is negative 1, so it should be one of those. Well, which one is it? Which pair is it? Well, if x is going to be positive at the end of the day, the 5 should be positive, right? Because the 5 is bigger than the 4. Think about it. If you have the 5, you keep the 5 positive and you make the 4 negative, when you go ahead and you FOIL the guy, you have, let's do firsts is x squared, outers is x squared minus times negative 4 is minus 4x, the inner is 5x times x, and the outer is, the last is 5 times negative 4, which is minus 20. Well, if you do that, because the 5 is positive and 5 is greater than 4, 5 is going to carry the day as far as which side of the 0 negative 4 plus 5 ends up at. So you'll have x squared plus x or plus 1x minus 20, which is what you want. So yeah, your instincts are right. The 5 should be the positive 5 or x plus 5, and the 4 should be negative. Okay, so we're good to go. We've taken this term and this expression or equation, and we've turned it into a new form, and we're happy about that. Okay, so what should the answer be? Should it be 6, 5, 4, or 2? And you're like, well, it's positive 5, so the answer is positive 5, right? And no, because we just did this. Because if you added in a positive 5, that would be 5 plus 5 is 10 times 1 equals 10. No, the answer is 4. Why? Because if x equals 4, you'd have 4 plus 9 times 4 minus 4. The 4 plus 9 equals 13. That times 0 equals 0. So we're good to go. If you swap out 4 for those terms, 4 for x here, you'd be good to go. If you swapped out 5, so 4 is the right answer. 4 is good to go. If you swapped out 5, that'd be 5 plus 5 is 10 times 5 minus 1, which is 1, and that does not equal 0, so you're not good to go. So it can't be 5, it has to be 4. That being said, if you wanted to just skip all that brain damage and throw 4 in here to begin with, you'll see that you're going to be in pretty good shape. 4 here would be 4 squared plus 4 minus 20, right? Because if you swapped out 4 for x, that's what you get. Does that equal 0? Well, 4 squared is 16, plus 4 is plus 4 minus 20. Does that equal 0? Well, yeah, it's 20 minus 20, and that does equal 0. So, I mean, that's a way to check your answer or just save yourself a lot of trouble. But we're good to go regardless. Okay, question 9. Which of the following sets of coordinates represent where a graph of the following equation would intersect the x-axis? Okay, so y equals mx plus b is a straight line. Here we have this form. It's going to be a smiley face or a frowny face, and we'll figure out where. First, what we should do is we should turn this phrase, this equation, into a form that we're more familiar with. So let's take 15, let's break 15 down into its components. We have 15 and 1, and we have 3 and 5. We know they're both going to be the same sign because you have a plus 15 here, and we know they're both going to be addition because we have a plus here. So what is it going to be? Obviously, it can't be 15 and 1. That added together will get you 16. So it should be 5 and 3. And shockingly, that does work. It adds together to get 8x. So we're going to take this guy, and we're going to turn it into y equals x plus 3 times x plus 5. Okay, so far good to go. Where do I get 0? Where do I get 0? I get 0 if x equals negative 3, right? Because if x equals negative 3, then this term equals 0, and this term times whatever this turns out to be will be 0, because 0 times anything is 0. So if we have negative 3 in here, that's 0, and that's positive 2. So that's positive 2 times 0 is still 0. So y equals 0 at negative 3. So we have negative 3, y is going to equal 0. Well, also, if you have x equals negative 5, then y is also going to equal 0, right? You know, that's not too shocking right now, right? Because if you have x equals negative 5 here, negative 5 plus 3 is negative 2, but that's going to be times negative 5 plus 5, which is 0. So negative 2 times 0 is still 0. Anything times 0 is 0. So y equals 0 when x equals negative 5. So what do you have? You have 2 points. You know, write these in XY notation. It's not scary. You learned how to do this a long time ago, right? This is just XY notation, right? So we have negative 3, 0. So let's go here. Negative 3, 0. And we have negative 5, 0. Okay, those are our roots. Those are where x those are where x is when y equals 0. That is where x is when y equals 0. We've just solved the equation like we've been doing all lesson, and x is now either a negative 3 or a negative 5, and either of those places, y equals 0. So what are my sets of coordinates? Well, we have negative 3, 0 and negative 5, 0. So what is that? That's B. We're good to go. All right, so side note, if you want to find out what the graph looks like, we'll just throw in some other points, right? So what if x equaled 0? 0 squared is 0, plus 8 times 0 is 0, plus 15. So at 0, it's going to be 0, 15, right? So now you get a sense of where this is going to go. You know, it's going to, and you know, it's going to look like this. It's a big happy face. We're good to go. In question 10, which of the following sets of coordinates represent where a graph of the following equation would intersect the y-axis? Okay, so we have negative here, so we know it's going to be different signs, and we have negative here, so we know that the bigger number is going to be negative. So how do you get to negative 12 and that with numbers that combine for negative 4? Well, let's try 6 and negative 2, or negative 6 and 2, right? And we kind of like are clued into that by the 6s and 2s hanging out here. Well, 6 times negative 2, that gets me to negative 12, and negative 6 times 2, that gets me to negative 12. Which two added together will get me to negative 4? Well, it's going to be negative 6 and 2, right? Because if we break it down like this, x minus 6 and x plus 2, and we run our FOIL, we know it's going to be negative 6 times x, add, those are inners, added to 2 times, positive 2 times x, which will get me to negative 4x. So hopefully that makes sense to you by now. So here we have, you know, two numbers that we're going to need to work with to get to y equals 0, because that's when they would intersect the x-axis. You intersect the x-axis when y equals 0. So how do you get y to equal 0? Well, if x equals 6, y is going to equal 0, right? Because 6 minus 6 is 0. And if x equals negative 2, y is going to equal 0. Okay. So if we have x equals negative 2, y is going to equal 0. And if we have x equals 6, y is going to equal 0. So those are our two spots. And if we want to stop there, where we certainly can, x equals negative 2, y equals 0, x equals 6, y equals 0. That's our answer. But let's graph this out just because it's fun. So where would, we know it's going to be either a smiley face or a frowny face because it's in that term that we're familiar with. So where would it be, where would the, where would y be when x equals 0? That's always an easy spot to find. Why? Because 0 is easy to work with. So if x equals 0, where would y be? Well, if we plug in 0 squared, that's 0, minus 0, 0 minus 0 is 0, minus 12, y would be minus 12. So we have y equals minus 12 when x equals 0. So that'll be way down here. And again, that's a rough sketch of our graph. We're good to go.